Good morning students. Today we will discuss about carbon resistors, color coding, mobility and derivation of Ohm's law. So let's start with carbon resistors. As we know that on the basis of requirement, the applications we can say the resistors are categorized in three types, and the first type is small value resistance. The small value resistance is required when we have to transmit power from one place to another place. At that point we have required a low value resistance, because as we know that when the power is transmitted, the energy is lost in the form of heat, and as we know that heat energy H equal to I square RT. Heat energy H equal to I square RT. So heat energy is related to resistance, and if the value of resistance would be high, then the heat energy would be more. So in that case we have required a low value resistance, and as we know that metallic materials such as copper, aluminium, these type of materials have a low value resistance and their resistivity is very small. So in the case of power transmission we required metallic wires made up of these type of metals. Second is large value resistance. When we have stopped to flow the current from one point to another point, at that place we have required a large value resistance. Basically the material or substance used for large value resistance is insulators and such as we can say bakelite, mica, etc. And the third one is medium value resistance. Medium value resistance, and the medium value resistance are mainly made up of semiconducting materials, and in that category semiconducting materials we have chosen carbon. There are two reasons to choose carbon for medium resistance. Is that first one is carbon making resistance making cost for carbon is very low. If we make resistors by using the carbon as a substance, the cost is very low. And second one is compactness. Carbon, when we made the resistors by using carbon, a large value resistance in mega ohm, it will take a small size to formulate to make that large valued in resistance by using the carbon. So these are two reasons. That's why we use the carbon, except all the other semiconducting materials like silicon and germanium. So mainly these are three categories of resistors. Now we will discuss about techniques through which we can evaluate the value of resistance. Any physical resistance has four different types of bands, and we are making a diagram so that you can easily understand the concept of color coding. So this is a figure of a resistor. In resistor, every resistor there are basically four bands of colors. I am placing it as, naming it as band name A, band name B, band name C, and the last one is band name D. So here the first band you are seeing, first color band A and B. These two, first A and second B, these are first color band denotes the first significant digit, and the second band denotes the second significant digit. The third band you are seeing named C, it is representing the powers of 10 and it is called multiplier. The value of C is multiplied to these two significant digits so that we can find out the value of this resistance. And what is the purpose of this fourth band D? It is fault tolerance band. It is called tolerance band, and it is used here to give the reliability. Reliability means here that we can say that the actual value of this carbon resistor would be between these upper and lower limits. So this tolerance band decided the range up to which the original value of this carbon resistor could be lie. So this is the theoretical method to which we can find out the value of this carbon resistors. So here I am giving you a learning method, and that learning method is well known as, we are writing it as BB Roy, grade BB Roy, grade Y BB Roy थे, grade Y थे, BB Roy great boy, very good wife. उनकी जो वाइफ थी बहुत गुड थी, तो वेरी गुड वाइफ. BB Roy great boy, very good wife. Here the first B denotes the color black and the significant digit allocated to this color is 0. Second color is brown. Second color is brown and the value designated to this color is significant digit is 1. Third one is red and the value is 3. Fourth one is orange and the value is 4. This one is yellow and the value is 5. For this grade we are taking only the letter Z. We are only taking the letter Z and G here stands for green and the value is 6. From here we are taking B and the color is blue and the value is 7. In very we are taking B, color is violet and the value is 8. Here we are taking Z again, the value, the color name is grey and the value is 0, 1. We are missing one term. Second, third, fourth, fifth, sixth, 7. This one is 8 and 5 say W and this color is white and here we can write letter 9. So this is a shortcut method to learn all the colors. What is this? BB Roy, great boy, very good wife. And first B stands for black and the significant digit is 0. Second B stands for brown and the value is 1. Third is red, value is 2. Fourth is orange, value is 3rd and so on. So this is the method you can write, you can learn all these colors and their significant digits. Now we will talk about the third band C, multiplier. So we are assigning all the multiplier values related to all the colors. So for black colors the value of multiplier would be 10 to the power significant digit is what? 0. So it would be 10 to the power 0. For brown color multiplier value would be 10 to the power 1. For red color value would be 10 to the power 2. For orange color value would be 10 to the power 3. For yellow color value would be multiplier value would be 10 to the power 4. For green it would be 10 to the power 5. For blue it would be 10 to the power 6. For violet 10 to the power 7. For grey 10 to the power 8 and for white 10 to the power 9. So these all are the multiplier values associated to all the colors respectively. Now we will talk about last band B, which is called tolerance band. Here we have 3 choices, 3 colors. First is gold, second one is silver and last one is no color. What it means no color? It means maybe there is absence of this 4th band, tolerance band. So for that we are writing here no color. So for gold the tolerance band limit is 5%, for silver it is 10% and for no color it is 20%. Okay, gold 5%, silver 10%, for no color it is 20%. ठीक है, यहाँ पर आप देख रहे हैं कि ये वैल्यूज परसेंटेज में है। जब हम इसकी फाइनल वैल्यू लिखेंगे तो ये जो परसेंटेज वैल्यू है इसको हम अपनी जो वैल्यूज आएगी ए बी सी की इसमें क्या करेंगे, ऐड और सब्ट्रैक्ट करेंगे, जिससे ऐड करने पर हमें एक अपर लिमिट मिलेगी और सब्ट्रैक्ट करने पर इतना परसेंट हमें एक लोअर लिमिट मिलेगी। तो एक्चुअल वैल्यू इस रेजिस्टेंस की जो होगी वो अपर लिमिट और लोअर लिमिट के बीच में डिसाइड करेगी, कहीं पर भी लाई कर सकती है। सो फॉर दिस मेथड वी कैन फाइंड आउट अ रेंज up to which the original value of any resistance could be lie. Okay, so this is first let's take an example to understand it in a better way. So here we are writing a example. Suppose the first color band A is red and B is we can say brown, and C is, let's take violet, and the D is gold. So what would be the value of this resistance on the basis of this color coding? So let's solve this problem. So for red color, as we know that for the red color BB Roy great very good wife, BB Roy great boy very good wife. यहाँ पर कई लोग ब्रिटेन भी बताते हैं, कोई उसमें हार्ड एंड फास्ट रूल नहीं है कि बॉय ही होगा. वी हैव ओनली टेकन दिस लेटर बी. सो बीबी रॉय यहाँ से हम रेड का हम देख रहे हैं सिग्निफिकेंट डिजिट हमारी क्या है 2 है. तो वी आर राइटिंग हियर फर्स्ट सिग्निफिकेंट डिजिट 2 एंड फॉर ब्राउन कलर इट इज 1. For brown color it is 1 and the violet is at the place 7 and the multiplier value for violet color is 10 to the power 7 and for gold it is 5%. So these are the values related to A, B, C and D. Now we will write final answer of this resistance. The value of resistance would be, सबसे पहले first significant digit हमने लिखी 2, next the second significant digit हमारी 1, इसका मल्टीप्लाई तो मल्टीप्लाई कर लीजिए 10 टू द पावर 7, फिर प्लस माइनस लगा कर 5% टॉलरेंस बैंड यहाँ पर क्या करिए पुट कर लीजिए. ओके, इस वैल्यू को हम लोग इसकी यूनिट क्या होगी ओम, तो इसको हम मेगा ओम में भी लिख सकते हैं. तो ये हो जाएगा आपका 210, एक जीरो में यहाँ पे प्लेस कर दिए. 10 टू द पावर क्या हो गया 6 प्लस माइनस 5%, इसको हम कह सकते हैं 210 मेगा ओम प्लस माइनस 5%. तो दिस वुड बी द आवर आंसर. तो ये हमारा जो आंसर है इसकी रेंज क्या है प्लस माइनस 5%, यानी इस वैल्यू का 5% अपर साइड, इसी वैल्यू का 5% निकाल कर माइनस करके लोअर साइड. तो दिस इज द टेक्निक, कलर कोडिंग टेक्निक थ्रू विच वी कैन फाइंड आउट द रेंज अप टू विच द वैल्यू ऑफ रेजिस्टेंस कैन लाई. ओके, so this is all about carbon resistance and color coding. Now we will talk about mobility and we have one more derivation left remain, that is Ohm's law by the drift velocity. So we will see it in this video. Here we are defining the drift velocity. Drift velocity not, it is it would be mobility. We have already talked about drift velocity. Mobility is denoted as symbol mu. Mobility is denoted as symbol mu. Mobility mu equal to Vd upon E. Vd upon E. So what is this mobility? It is the ratio of drift velocity to the electric field applied across the material. It is simply the ratio of drift velocity to the electric field applied across the material. So this is the general formula. We can write it general formula. When we say that this is the general term and this is the general formula, general form, so it means that we can apply this formula for every material, whether it is semiconducting materials or it is metals. So this is general formula. Now we can evaluate the units of this mobility here. So unit of mobility, now we will talk about unit of mobility. Unit of mobility equal to, यहाँ पर Vd आपको पता है ड्रिफ्ट वेलोसिटी, तो इसकी यूनिट क्या होगी मीटर पर सेकेंड. Now the unit of E, ये आपका क्या है इलेक्ट्रिक फील्ड इंटेंसिटी. इलेक्ट्रिक फील्ड इंटेंसिटी की यूनिट हम यहाँ पर इलेक्ट्रोस्टैटिक्स वाली नहीं प्लेस करेंगे, यहाँ पर हम प्लेस करेंगे E इक्वल टू V/D से या V/L से. ठीक है, क्योंकि हम लोग इलेक्ट्रिसिटी पढ़ रहे हैं तो इन टर्म्स ऑफ वोल्टेज. तो ये आपका क्या है वोल्ट पर लेंथ की आपकी क्या होती है मीटर. तो वोल्ट पर मीटर यहाँ पे हम पुट करेंगे तो ये आपका हो गया वोल्ट पर मीटर. मीटर आपका कहाँ जाएगा, ये ऊपर जाएगा, तो मीटर इंटू मीटर स्क्वायर अपॉन ये आपका बना वोल्ट सेकेंड. So this is the unit of mobility. In the same way, we can find out the dimension of mobility. Mobility is a vector, scalar quantity. यहाँ से हम इसकी डायमेंशन कैसे निकालेंगे. Vd की डायमेंशन क्या होगी, Vd की डायमेंशन mRLT-1 और E की डायमेंशन आप कहाँ से निकाल लेंगे, ये आपका चैप्टर नंबर 1 कूलम्स लॉ से F इक्वल टू QE. F इक्वल टू क्या होता है आपका क्यूई फोर्स की आपको पता है क्या होती है, ml t-2, चलिए निकाल ही देते हैं। फोर्स की आपकी है ml t-2, क्यू बराबर IT, तो ये आपका हो गया 80, IT का ये 80, और E की आपको डायमेंशन चाहिए, इसको ऐसे रखते हैं, Q इक्वल टू IT से हमने निकाल लिया, इसको आप नीचे ले आएंगे तो ये आपका हो गया ml a-1 t-3, ये आपका हो गया ml a-1 t-3, ml a-1 t-3. So this is the unit of electric field intensity, and we know that the unit of this we can place it here. तो डायमेंशन ऑफ म्यू, डायमेंशनल इक्वेशन आपकी क्या आ जाएगी यहाँ से, ये हो जाएगी LT-1, और इसकी डायमेंशन आपकी हो गई ml a-1 t-3. इसको सॉल्व कर लेते हैं, ये आपका हो जाएगा L से L देखिए कैंसिल हो रहा है, तो ये आपका m-1, ये ऊपर चला गया, t की पावर ये आपका हो जाएगा माइनस ऊपर गया तो 3-1 2, तो ये आपकी वैल्यू आ गई m-1a t2. दिस इज द डायमेंशन ऑफ मोबिलिटी. नाउ वी विल फाइंड द रिलेशन बिटवीन द कंडक्टिविटी एंड मोबिलिटी फॉर द मेटल्स. So for the metals we will find the relation between conductivity and mobility. Conductivity and mobility. Conductivity and mobility. Mobility for metals. So metals के लिए क्या relation आएगा? As we know that the formula for mobility, general formula, V equal to mu equal to Vd upon E, and we have already known I equal to NEA Vd. यहाँ से हम Vd की वैल्यू निकाल लेते हैं तो ये आ जाएगी I upon NEA, ये आपका क्या आ गया Vd. ये वैल्यू उठा के हम यहाँ पे पुट कर देते हैं तो mu इक्वल टू आपका आ जाएगा, Vd की वैल्यू यहाँ पे पुट करते हैं I upon NEA, और E को हम पुट करेंगे E इक्वल टू V बाई L. E की वैल्यू हमारी क्या हो गई V बाई L. L आपका कहाँ गया ऊपर, ये आपका बन गया म्यू. I अपॉन V आपको पता है V इक्वल टू क्या होता है IR, तो I अपॉन V अगर आप करेंगे तो ये वैल्यू आएगी आपकी 1 बाई R. तो I अपॉन V की जगह 1 बाई R यानी L अपॉन NEAR. उसके बाद आपको पता है रेजिस्टिविटी यानी स्पेसिफिक रेजिस्टेंस, हम लोग प्रीवियस लेक्चर्स में डिस्कस कर चुके हैं. रेजिस्टिविटी आपका क्या है RA बाई L. तो यहाँ से RA आपको दिख रहा है, L को आप नीचे लिख सकते हैं, यानी कि ये वैल्यू आपकी हो जाएगी 1 अपॉन NE रो. ठीक है, और 1 बाई रो आपको पता है रेजिस्टिविटी, रेसिप्रोकल का क्या होता है, इसका रेसिप्रोकल कंडक्टिविटी. इसको NE को आप इधर भेज दिए तो म्यू NE म्यू इक्वल टू 1 अपॉन रो, और 1 अपॉन रो इज सिग्मा. तो दिस इज आवर द रिलेशन सिग्मा इक्वल टू NE म्यू. This is our final relationship between conductivity and mobility for the metals. Okay. For semiconductor, we will not discuss the derivation because you students are not well known about the semiconducting materials. So we will not discuss it. We will discuss it when we read the chapters in the classes, regular classes. Now we will talk about the derivation of Ohm's law. Derivation of Ohm's law. Derivation of Ohm's law. Let's start with derivation of Ohm's law. As we know that in case of conductor, we have derived this relation I equal to NEA Vd. Keep in mind, N is what? N is number of electrons per unit volume. N is number of electrons per unit volume. Now, as we know that when we connect any material, conducting material through an external source such as battery, then there is an electric field, and by the electric field we can write this relation E equal to V upon L. What is L? L is the length of that conductor. You can figurize this. So this is conducting material and this is external source. Okay, so this is potential difference B, this is the length of conductor L, और ये आपकी क्या है +2 माइनस इलेक्ट्रिक फील्ड E. Okay, so E equal to V by L, as we know that in the electrostatic chapters, when a charge carrier is placed in a electric field, then there will be a force, and that force is called electrostatic force, and we can write F equal to QE. Q यहाँ पर हम E से रिप्रेजेंट कर रहे हैं, E इंटू E. F इक्वल टू QE से ये हमारा रिलेशन आ गया, F इक्वल टू E इंटू E. E की वैल्यू आपको पता है क्या होती है, 1.6 इंटू 10⁻⁻⁹. ओके, नाउ F इक्वल टू QE. Secondly, we can say that according to Newton's second law, if there is a force, if there is a net force, then there would be a acceleration. So there would be acceleration. So we can say F equal to ma. We can say F equal to ma. So here from these two equations we can write E into E equal to ma. And E की वैल्यू हमने यहाँ पे क्या पुट करते हैं, V by L. This is ma equal EV upon L equal to ma. यहाँ से हमारा A आ जाएगा, A की वैल्यू यहाँ से आ जाएगी A equal to EV upon ml. EV upon ml. A equal to EV by ml. So this is our equation number first, and we are placing this at equation number 8. This is equation number first है, इसको करेंगे second, इसको करेंगे first. Now we will talk about drift velocity. We will find the drift velocity. So as we know that before applying the electric field, before applying externally in the electric field, the free electron present inside the conducting material will move with its initial velocity, and that velocity is called the thermal velocity. And when we apply electric field across this material, all the electrons will drift towards the positive terminal of the battery, and that velocity is called, average velocity is called drift velocity. So let's assume that there are n number of electrons per unit volume, and the initial velocity of first electron is u1. Here u1 is representing the thermal velocity before applying the external electric field. Second electron is the velocity is u2, third electron velocity is u3, then u4 and so on till un. These are all the thermal velocities of all the electrons. Now, for first electron, we are taking the time t1. What is this time? This is the time between two successive collisions. This is the time interval between the two successive collisions. It means if an electron, suppose these are the positive ions, and if the electron is moving and it is colliding this ion, and it after changing its direction, it is going towards another positive ion, and before collision to this ions, what is the time between from reaching this electron to this ion? This time is denoting here tau1. Similarly for second electron, this is time tau2, tau3 and tau4 and so on, tau n. Okay, now we will find out when we apply the electric field, this electron there would be a force, and if there would be a force, there would be a acceleration, and if there is an acceleration, there is a change in velocity, and the electron gets its new velocity, and we will find out that velocity by using the Newton's equation of motion for uniformly accelerated motion, and we know that V equal to U plus AT, and for this first electron, this velocity V1 equal to initial velocity U1 plus acceleration A and time interval between successive collision in tau1. Similarly, value of V2 is equal to U2 plus A tau2, because acceleration would be constant. It is not different for different electrons, because all the electrons would be accelerated in the same manner. Now finally n1 up to Vn equal to Un plus A tau n. ठीक है, अब यहाँ पे हम लोग ड्रिफ्ट वेलोसिटी की बात करेंगे, तो इन सभी वेलोसिटीज का यहाँ पे हमें क्या करना है, एवरेज लेना है. तो एवरेज के लिए हम लोग क्या करेंगे, Vd इक्वल टू V1 प्लस V2 प्लस V3 प्लस एंड सो ऑन Vn अपॉन में हमारा क्या हो गया n. ओके, we will put all these values V1, V2, Vn in this equation